Hello everyone, welcome to this advanced geospatial analysis presentation. In this study, we are working on multi-frequency SAR data fusion by combining C-band Sentinel-1 and L-band pulsar, two datasets to perform multi-temporal urban land use and land cover classification over the Kolkata region. For the years 2017, 2021, and 2025. This is a complete end-to-end geospatial workflow integrating SAR pre-processing, feature engineering, machine learning modeling, change detection, and urban morphology analysis. First, let us understand the study area. The region is centered around Kolkata with an approximate buffer of 20 kilometers, representing a highly dynamic urban landscape where continuous transformation of vegetation and agricultural land into built-up areas is taking place. Now, moving to the methodology, C-band Sentinel-1 captures surface scattering, while L-band pulsar 2 captures subsurface structural information due to its longer wavelength. SAR preprocessing includes dB to linear conversion, gamma MAP speckle filtering, and, for C-band, radiometric terrain correction using slope, aspect, and local incidence angle. L-band data is already terrain corrected, so only masking and normalization are applied. Feature engineering generates 18 features from C-band and 10 features from L-band, including backscatter, indices like DPRVI, texture features, and seasonal variations. These are combined into a 2-8 feature fusion dataset. A random forest classifier is used, where 36 models are trained using 3 training and testing splits: 70% training and 30% testing, 75% training and 25% testing, and 80% training and 20% testing. Stratified sampling is performed using SAR world cover reference data, and evaluation is done using accuracy metrics like OA, kappa, precision, recall, and F1 score. The fusion model performs best due to combined surface and subsurface information. Now, let us move to the outputs. Now, starting with output 1, this represents the reference land cover map, where red indicates urban areas, green vegetation, blue water bodies, and orange agriculture. The central region is dominated by urban areas, while vegetation and agriculture dominate the outskirts. Output 2, output 3, and output 4 belong to the C-band classification category. Now moving to output 2, which represents 2017. Here red urban areas are relatively limited and concentrated in the central region, while green vegetation and orange agriculture dominate the outer areas. Next, let us observe output 3 for 2021, where red urban areas increase compared to output 2, especially along the edges indicating expansion, while vegetation and agriculture begin to decrease. Now coming to output 4 for 2025, here red urban areas further increase and spread outward, while green vegetation and orange agriculture reduce significantly compared to previous years. Output 5, output 6, and output 7 belong to the L-band classification category. Now moving to output 5 for 2017. Urban areas appear smoother, with green vegetation more continuous and agriculture clearly visible. Next, observe output 6 for 2021, where red urban areas increase slightly compared to output 5, while vegetation and agriculture begin to reduce. Now moving ahead to output 7 for 2025, urban expansion continues, but boundaries are less sharp compared to C-band, although the increase in urban area is still clearly visible. Output 8, output 9, and output 10 belong to the C and L fusion category. Now let us examine output 8 for 2017, where class separation is clearer with well-defined urban, vegetation, water, and agriculture. Next, moving to output 9 for 2021. Red urban areas expand further compared to output 8, especially along the periphery. Finally, in this group, output 10 for 2025 shows maximum urban expansion, while vegetation and agriculture reduce further, making this the most accurate representation. Output 11, output 12, and output 13 belong to the urban-only category. Now moving to output 11 for 2017, urban areas are concentrated mainly in the core region. Next, observe output 12 for 2021, where urban areas expand outward compared to output 11. Now coming to output 13 for 2025. Urban extent is maximum, showing strong expansion and densification. Output 14 to output 19 belong to the change detection category. Now let us look at output 14, which shows overall change, where white indicates no change, red indicates urban gain, blue indicates urban loss, and dark maroon indicates stable urban. Red areas dominate, showing strong urban growth. Next, moving to output 15, which shows only urban gain in red, mainly around the outer regions. Now observe output 16, where blue indicates urban loss, which is minimal. Next, coming to output 17, which shows gain source, where green indicates vegetation to urban, orange agriculture to urban, and blue water to urban. Most changes occur from vegetation and agriculture. Now moving to output 18, which shows urban gain from 2017 to 2021, indicating initial expansion. Finally, observe output 19, which shows urban gain from 2021 to 2025, indicating faster and more intense expansion. Output 20, output 21, and output 22 belong to the morphological change category. Now moving to output 20, where red indicates increase, blue decrease, and white no change, highlighting increasing urban density. Next, observe output 21, which shows subsurface structural change with similar color interpretation, indicating internal urban transformation. Now coming to output 22, which shows normalized structural change, where red regions indicate increasing complexity and blue regions indicate reduction. Output 23 to output 28 belong to SAR feature visualization. Now moving to output 23, which shows C-band backscatter in grayscale, where white indicates high backscatter and black low. Next, observe output 24, which shows L-band backscatter with similar interpretation. Now coming to output 25, which shows incidence angle using a blue to red gradient. Next, moving to output 26, which shows normalized backscatter in grayscale. Now observe output 27, which shows DPRVI index where higher values appear greener. Finally in this group, output 28 shows entropy, where brighter areas indicate higher texture complexity. Output 29 and output 30 belong to sampling. Now moving to output 29, which shows training samples in yellow. Finally, observe output 30, which shows validation samples in cyan. In conclusion, urban areas represented by red have significantly increased from 2017 to 2025, while vegetation and agriculture have decreased. Multi-frequency SAR fusion provides the most accurate and reliable results compared to single-frequency approaches. Thank you for watching. If you found this useful, please like, share, and subscribe. For any kind of professional services, including geospatial research, AI model development, microwave remote sensing, thermal and optical remote sensing, and WebGIS, you can contact anytime.